Alright, for part 2 today, we're going to look at limits of piecewise functions. These are pretty easy to do, kind of fun to do as well. So what we're going to do is we're going to take a look at a piecewise. Now for a piecewise function, we're looking at normally where it splits, where the piecewise graph would split. So if I were to graph this function right here at, if I plug in 10, if I want to graph this, it splits at 4. So if I take x squared minus 10, that's going to give me a value of 6. So I know it's open. So I know anything to the left is opening up, like a parabola. Looking at the line down here, or the square root, if I plug in the 4 here, I get 2 plus 4. So it's also going to be 6, but now it's going to be a square root function, like so, if I were to graph that. Now, looking at this function, does it look like the limit exists at 4? Yes. The limit exists at 4. Whoops, x equals 4. We'll just write it that way. Now, but how can we show that mathematically? Well, very easy to do. Now, if you don't want to graph it, you can just use a little bit of algebra. Now, if I want to find the limit as x approaches 4 from the left of f of x, I just have to determine which function it's on. And I look at the symbol. The less than symbol right here, that means I'm coming in from the left. So if I want to find the limit as x approaches 4 from the left, I'm going to use this x squared minus 10. And what am I going to plug in? My substitution from before. I plug in that in 4. And I get 4 squared minus 10, which is 6. So there's my limit from the left. If I go from the right, well, that's my greater than symbol. That's talking about from the right. And that's going to put me on the square root. So I'm going to use the square root of x plus 4. And again, just like before, I substitute it in. So we get the square root of 4 plus 4, which is again 6. Now the question, does the limit exist at 4? And the answer, of course, is yes. It is 6. And why is it 6? Well, let's take a look here. Does the limit exist at 4? Yes. And the reason why? Because the limit, and just like from the other day, as x approaches 4 from the left equals the limit as x approaches 4 from the right of our function. In other words, the left equals the right. And that's what you're looking for on these. So let's take a look at a few examples, how we can do these. Let's take a look at number 1. If I want to find the limit as x approaches 3, follow the directions. We need to take the left hand and the right hand, and we need to compare them. So I'll take the limit as x approaches 3 from the left, and what I do is, which one of these is on the left? That's this one. It should be negative 3. Sorry about that. Or positive 3. Should be a 3 there, not negative. So this is the left side, and we're going to use this equation, so I just write it out. 3x plus 2. And I just plug in my x. 3 times 3 plus 2. It doesn't matter left or right, we just plug in the 3. Equals, that becomes 9 plus 2, I get 11. Take the limit as x approaches 3 from the right. Now I've got to take the right-hand limit. That's the bottom. There's our right-hand limit. And that's 1 over x plus 4. Same thing, plug in your x. We get 1 over 3 plus 4, which is 1 over 7. And I compare. They're not equal. So does the limit exist? No. The limit does not exist. And of course, write out your reason, because the limit as x approaches 3 from the left of our function does not equal the limit as x approaches 3 from the right of our function. And there's your reason. Let's try number 2. I need the limit as x approaches, we're approaching pi from the left. There's my left side. I'm going to use the sine of x. And that becomes the sine of pi. Well, what's the sine of pi? 0. Now I take the limit as x approaches pi from the right. That's going to put me on my bottom function. Cosine of x minus 1. Plug in your pi. cosine of pi minus 1. Well, cosine of pi, that's negative 1. Negative 1 minus 1 is a negative 2. So, do these equal? No, they're not equal. So again, it's D and E, and the reason because the limit as x approaches pi from the left does not equal the limit as x approaches pi from the right. Remember, the only time you ever have to write down a reason if it does not equal. So let's try 3 and 4 real quickly. Let's try number 3 here. For number 3, we take the limit as x approaches this time negative 2 from the left. Again, that's going to put me on the top one. X squared plus 3. Be careful. This is negative 2 squared plus 3, and that becomes 7. Take the limit as x approaches negative 2 from the right. That puts us on the bottom one. We get x cubed plus 1. Whoa, I wrote that completely wrong. Let me fix that. Negative 2 from the right of x cubed plus 1. There we go. That's better. That's a terrible format. And we're going to plug in the negative 2. We get negative 2 cubed plus 1. We get negative 8 plus 1, which is negative 7. Close, but no cigar. So again, this is a D and E because the limit as x approaches negative 2 from the right of our function does not equal the limit as x approaches negative 2 from the left of our function. All right, so see if you can try number 4 on your own, and we'll come back and take a look at this one tomorrow. This is a slightly harder one, okay? Weird, none of them worked out. Okay, so we'll take a look at that one tomorrow, okay? And we'll see you then. Have fun.